Hello everybody, this is Philip Jonas at Kalamazoo Valley Community College presenting OpenStax Principles of Economics, and today we're covering sections 5.3 and 5.4, Elasticity Applications. In this module, you will learn how to analyze the impact of price elasticity on revenue, how elasticities affect changes in equilibrium, how price elasticity determines the incidence of attacks, and how to calculate other elasticities. In our previous modules, we have learned to classify our elasticities as unitary. That's that magic point when the elasticity is equal to the number 1, which of course means that our percentage change in quantity and our percentage change in price are equal. And then elastic, if the percentage change in quantity is greater than the percentage change in price. Inelastic, if the elasticity comes out to be less than the number 1. So here is why this is such a useful classification scheme. If you have elasticities between points equal to 1, unitary, those points along a demand curve will give you constant total revenue. But what if your demand is elastic? That means if you raise price, people stop buying your product quantity faster than you're raising price. And since the revenue of your business is price times quantity, this means that raising price will actually lower your revenue. Now again, we're just talking revenue, not profit. From a profit standpoint, it might still make sense to take a look at raising price. We really have to look at the cost of production. We'll do that down the line. But it will lower your revenue. So perhaps for now, while we're looking at revenue in isolation, just imagine you're trying to price a product where you don't have additional cost of production. So for example, let's say you're selling a piece of software online, right? It's already written. Each license holder is going to pay you an amount of money, but there's no additional production cost. And let's pretend there's no support cost either. All right. And then over on the inelastic side of things, on the other hand, if you raise their price, customers cannot decrease quantity as fast as you're raising price. So your revenue is actually going to go up if you raise price on an inelastic product. So once again, let's look at this as like a range. In the middle of that range, if demand has unitary elasticity, your total revenue is constant. That's the actual mathematical requirement. But typically what that means is that if you're looking at constant revenue at a point on your demand curve, unless it's a very unusual demand curve, that's going to be the maximum revenue you can earn. And then as we look at less elastic demand, here raising price would make your revenue go up, while with elastic demand, raising price would decrease your revenue. So let's start out by looking at a demand schedule so we can actually look at a range of elasticity figures. So here's the demand schedule with some elasticities that are already pre-calculated for you. Now, notice that dash up here. An elasticity is the percentage change of two variables between 2 points. So technically, this number is sort of in between these two rows. Every time you look at a demand schedule that also involves elasticity, you want to make sure you realize between which two rows this elasticity number applies. So in this example, since the first row contains the dash, the 2.71 elasticity is between the 60 and 80 quantity and the 20 and 18 price over here. So as we travel down this demand curve, it is elastic, above 1. So raising price here would actually lower our revenue, but if we lower prices, our revenue starts increasing until we reach the constant revenue point, which is typically the max right here, number 1. And then if we lower price further, inelastic demand now, revenue starts dropping again. Let me show you the actual revenue number so that you see how this works, okay? So for each row, revenues here calculated, we start at a number that increases when we drop price until it reaches a max, starts decreasing again. Or if you want to think of it in terms of rising price, raise price on an inelastic demand, revenue increases until you hit a max, keep raising price, revenue starts decreasing again. You can see the maximum happens when the elasticity is equal to the number 1, which again applies in between two rows. So this number 1 calculation is based on the 120, 140, $12, $14 rows. So you see in between those two rows, our revenue stays constant. And if we want to dig a little further, like maybe in between here sits a row, we don't have the numbers, that's $13 at 130 units. That would of course be $1,690, so an even slightly higher number. But it's that unitary elasticity we're hunting for to determine our maximum revenue potential. So this is using the example of a demand schedule that has varying elasticity. But now let's also look at some of our familiar extremes. So here is the demand curve facing a single firm. We're not talking about market demand. We're talking about just from the perspective of one firm. What does the demand for your product look like? And you're looking at a horizontal line, which by now, of course, means a perfectly elastic demand curve, where if you try to calculate that elasticity, that's undefined since there's no percentage change in price. So what's going on here? How would you price this, right? That there's no number 1 on this whole demand curve. Well, what we're looking at is we have a price where if we bump the price of our product up even a little bit above that price, quantity demanded immediately goes to 0. This is referred to as being a price taker. And it seems like the term already applies. Here, what we have to do, we simply have to accept this price as given. We don't have a pricing decision at all. So this happens when you are in a very competitive market selling a completely undifferentiated product. Let's say you run an oil well. There are many decisions you can make when it comes to running an oil well. How much oil do I want to pump? Who do I want to employ? It's your business. But the product, oil, is in such a competitive market, so undifferentiated that when it comes time to sell it, there's a market price and you don't have a choice. You simply have to accept that market price. You could choose to charge less, but that wouldn't be very smart because, again, it's such a huge market compared to you. You can sell as much as you want at that market price. So that's it. You are a price taker. Let's look at the theoretical opposite of this. What do we have? A demand curve that looks like this. Again, not market demand. Demand curve facing an individual company. So here, no elasticity. Elasticity 0. Perfectly inelastic demand. Theoretically, what this means is if you raise price by any percentage, since there's no change in how much is being bought, your revenue will increase by that same percentage. So, charge the moon, increase price, revenue only ever goes up and you don't even have to produce anymore. Fantastic. And you might even sometimes hear, hey, if you're selling a product that people need, perhaps the demand of your business looks like this. But that's wrong, because an individual business facing a demand curve like this is super unlikely. What this demand curve implies is that there's no other business selling the same product. There's no competition. Even if people need your product, typically if you raise price, they have the option of perhaps buying from somebody else. It also implies that there are no substitutes whatsoever where people can maybe switch to something related that's similar, perhaps still a great need, but not precisely what you are selling. And it of course implies that your customers have an unlimited ability to pay, which also seems highly unlikely. So again, individual business facing a demand curve like this, highly unlikely, but if in the future you encounter a policy problem where this actually does apply, perhaps a company has an outright monopoly on a thing that's life-saving and no alternative exists, well, then actually we're going to be in a situation where perhaps the usual efficiencies of let the market decide what the price is no longer makes a lot of sense. So these are these extremes from the perspective of an individual firm. But of course, we do notice when we look at entire markets, sometimes when there are disruptions or cost increases in the market, man, prices sure seem to go up a lot. Like the firms do have a lot of power, even if there is competition. And that's when elasticity analysis gets really interesting. Let's look at an entire market demand and supply curve. So here it is, existing at some sort of equilibrium at the moment. And then something happens that decreases the supply of that product. Like let's say we've got a supply chain disruption that drives up cost. We've already learned in the previous module. How do you model a cost increase? Well, that's a decrease in the supply of the product. So we're going to take that supply curve, shift it to the left. And we already know if supply shifts to the left, we end up with a new equilibrium where price is higher and quantity is lower. But elasticity lets us really add to that picture. What if this happens in a market where the market demand is relatively inelastic? Like for example, let's say that it becomes more expensive to provide housing. And housing has a relatively inelastic demand on account of people need a place to live. And yes, you can adjust it. You can live in a smaller place. You can have roommates. But people are hesitant to do that, right? So relatively inelastic demand. We look at that decrease in supply on an inelastic demand curve. And what do we see? Most of that decrease ends up raising price with a relatively small change in quantity down here. Let's compare that with what happens if supply decreases and demand is relatively elastic. So we're going to look at a similar graph, but I'm going to make that demand curve more elastic. So look for it to flatten out. Here is a more elastic demand curve. Again, we have a decrease in the supply of the product. To the left, the supply curve goes. Once again, of course, price up, quantity down. But elasticity lets us really add to this picture. We see that this time the price rises relatively little and people just cut back on buying that product. So what sort of elastic product is that? Well, let's say, for example, this is more of a luxury product. Like let's say it becomes more expensive to offer cruises to people. Cruises might be a great vacation, but nobody needs to go on a cruise. So you see a cost increase there. Firms will not be able to pass that on to consumers very much, and therefore quantity will decrease. So let me repeat this one more time. Can firms pass a cost increase on to consumers? The answer is it depends. It depends on the elasticity of demand. If the elasticity of demand is relatively low, yes, price is going to go up a lot. If it's relatively high, no, consumers are flexible and that price will only increase a little. Of course, this works in both directions. So let's look at a cost decrease real quick as well. If we have a cost decrease and shift supply to the right, price falls, quantity increases. In the context of an inelastic demand curve, that'll go ahead and give us a relatively large reduction in the price of the product. If this happens with a more elastic demand curve, on the other hand, let's go ahead, take that supply curve, shift it to the right. Price decreases just a little bit. while quantity increases quite a lot. So next, let us look at what you might consider to be a particular type of cost increase. What if we impose a tax on this product? So if we have a tax that's on a specific product, we call that an excise tax in economics to distinguish it from taxes on, for example, incomes. That would be an income tax. And excise taxes, very interesting. You can model those in the model of supply and demand. Up until now, when we've looked at supply and demand, we've looked at the idea of an equilibrium price that brings quantity supplied and demanded into balance. That's what equilibrium means. Quantity supplied and demanded are in balance, but at one price, a price that the consumers pay and that the producers receive. An excise tax splits that one price into two. Consumers now pay a price, but producers receive less than what the consumers pay because of that tax in the middle. It's like when you go to the store in a place that has a sales or value-added tax. There is the price of the product that the merchant gets to keep, and then there's that higher price, including the tax, that you are paying. So we're going to shortcut many of the mechanics of how to implement an excise tax here in the model of supply and demand. All I need you to really know is there's now two prices that are apart from each other by the amount of this tax. And we've got that indicated here with this brace. So this is how much tax we have to wedge in between the consumers and the producers. So we're still hunting for an equilibrium, a point where quantity demanded is equal to quantity supplied, but it'll happen at two different prices for the consumers and the producers. So we take this tax wedge and we jam it in between the demand and the supply curve. Right here, we have a price that the consumers pay, giving us a quantity demanded that is equal to a price that the producers receive, giving us the same quantity supplied on that supply curve. So again, we've got that tax wedge driven in between our supply and demand curves. Notice the difference between those two prices here, equal to the size of that wedge. And again, still in equilibrium, so quantity supplied will equal quantity demanded. I'll go ahead and call that an after-tax quantity. So notice in this specific example that the tax relative to the old pre-tax price, the equilibrium price here, doesn't affect the buyers and sellers the same. From the perspective of the buyer, the new price they have to pay is a relatively small increase. While from the perspective of the seller, what they receive decreased by quite a bit. This is what we call tax incidence in economics. The idea that when you place a tax on a product, it's not simply that like consumers pay all of it or producers pay all of it or it's shared 50-50. What actually happens is an interplay of the supply and demand curves. We have the tax wedge. We put it in between the supply and demand curves where it again gives us an equilibrium. And the way this wedge plays out is determined by the elasticity. In this first example, the consumers are relatively more elastic. Look at the shape of that demand curve. It's flatter than the shape of the supply curve. There is more quantity response for a given price change. If this is the case, if the elasticity of demand is higher than the elasticity of supply, you can almost think of this as the consumers being more powerful in this market. You introduce a tax, most of the impact of that tax falls on our producers. By the way, while we won't go in depth in taxes, this application means we can also calculate the revenue of a tax, because we know how much is being paid per unit. That's this vertical wedge here, the difference between the price of the consumers and the price of the producers. And we know how many units are being sold after the tax is implemented, after tax quantity. So you take the size of the tax times that quantity. As a result, you get a rectangle representing tax revenue. Again, vertical times horizontal, multiply, you get an area. You get a rectangle area. So let's do this again, but tweak those elasticities. Look at this market. Now the demand curve has a relatively lower elasticity. It's steeper, lower quantity response. And the supply curve has gotten flatter with a higher quantity response. So we start from an equilibrium, no tax. And now we take a given excise tax, here's our wedge, jam it in between the supply and demand curves, finding ourselves a pair of prices apart from each other by this wedge, but giving us the same x coordinate, the same quantity coordinate on the supply and the demand curve. That gives us the prices that the consumers are paying and that the producers are receiving after the tax is implemented. Notice, the balance has shifted, right? This time, the consumers are relatively more dependent on the product. So the amount of the tax incidence that falls on them by virtue of their price increasing is much bigger than the share of the tax that falls onto the producers. You may notice the analogy here to the cost example. If there's a cost increase on an inelastic demand, price goes up a lot for the consumers. Same here. And again, this is an equilibrium. Quantity supplied equals quantity demanded. So we have our after-tax quantity down on the x-axis relative to that vertical tax wedge. Once again, we can also calculate the amount of tax revenue as the product of QT and the difference between PC and PP, the tax wedge. So this is how we can use elasticities to think both about cost changes and about the impact of taxes on a market. But we're not yet done with the topic of elasticity. Because so far, we've looked at elasticity at one point in time. However, elasticities change over time. Elasticities measure how much consumers and producers can respond to changes. And the more time you give individuals to respond, the more they can respond. So that's why when it comes to questions of elasticity, it's often important to look at the time frame of the question. Let's do a cost increase one more time, or you can think of this as a tax as well if you want to. If you have a cost increase, a decrease in supply, and in the short run, consumers are relatively dependent on the product, you see this big increase in price, right? There's many examples here you could use. So for example, if gas gets more expensive, in the short run, consumers are really dependent on just buying the gas they need to get to their weekly destinations. So this decrease in supply gives you a big price jump, small decrease in consumption. But if gas stays less available over time, consumers do have certain behaviors they can change. They start living closer to work. They start driving different types of cars. Car makers respond and start prioritizing fuel efficiency more because this is now a bigger concern for consumers. We might even see shifts all the way over to electric vehicles, right? We're sort of at the beginning of that transition. Or let's say we're looking at an increase in cost for hotel rooms in a touristy area. At first, that cost might just be passed on to consumers because they've already made their vacation plans. Vacations have been planned long ahead. So they might be locked in. But give it a few years, consumers will respond and shift where they vacation. So this elasticity will increase over time. So let's look at these supply decreases, whether it's gasoline or cost of hotel rooms, over a longer time period as consumers have greater elasticity. Let's flatten out that demand curve, right? And what do we notice? As we flatten out the demand curve, that same cost increase, that same left shift of the supply, very different impact now. The price increase, much more moderate, because with more time, consumers are able to cut back more. And as they cut back more, they can hold those prices down. Most extreme example perhaps of this would be during a temporary sort of bad news situation, unexpectedly severe weather, or maybe hopefully not too bad of a natural disaster. For that very short time period, elasticities are super low. So if there are supply disruptions, you can see prices just skyrocketing. And that's then where we end up with conversations about what constitutes price gouging, which frankly, there isn't a very good definition of that we can apply here in the context of economics. But that's certainly where the resentment is coming from, that in a crisis situation in the short term, your elasticity is super low. So these are our price elasticities of supply and demand. Certainly the main applications of elasticities for our purposes. But that's not the only use of elasticity. Elasticity is just measuring the change of one variable in response to another variable changing. You can apply that in so many circumstances. I'll mention a couple more here from economics, but you can even look beyond that. So two more that we absolutely have to mention here are the income elasticity of demand and the cross-price elasticity of demand. So both of those obviously on the demand side. And then we have two others on the supply side that often come up in policy discussions. The elasticity of labor supply and the elasticity of savings. So here we're talking about things such as how much should you tax working and how much should you tax, for example, the returns to saved money. And those are implicitly often discussions about the relative elasticities, because the question is, if you increase taxes on working, how much do you decrease the incentive to work? That's an elasticity question. But we're going to finish out by looking at those last two demand elasticities. First, the income elasticity of demand. So we're looking at how much does the quantity demanded of a product change, not due to a change in the price of that product, but because the incomes of the customer base change. And here, the big pivot point really is the number 0, not the number 1. So what I mean by that is that a positive or a negative elasticity? We actually have to track the sign here. It's very important. A positive elasticity means that if people have higher incomes, they buy more of this product. This is very common. Most items, when incomes go up, people buy more of these items. So common, we literally call that normal. Now, in our lectures, we discuss this in terms of quantity. If you go to higher level economics, you learn how to also put quality into that quantity demanded. So when I talk about higher income leading to higher quantity demanded, this might actually be the same number of units, but buying nicer versions thereof as well. But with the income elasticity of demand, there is the potential that higher incomes lead to buying less of something, or perhaps more intuitively, that when your income drops, you buy more of something. So we call that an inferior good in economics. For example, if you lose your job, you might also lose your car and as a consequence buy more bus tokens, making those an inferior good. So two things to note here. Inferior does not mean bad in economics. bus tokens are a super useful thing, right? Like, and even if you have lots of money, you might want to take the bus from time to time for many reasons. It simply means as people's incomes drop, they switch more into that product category. As incomes rise, they switch out of the inferior good category. And you can probably realize immediately that even macroeconomically, this can end up being very significant. If, for example, our economy enters a recession and incomes sort of drop on a major scale, companies that produce inferior goods, maybe a little counterintuitively, actually end up doing better in such a recession. You know, people lose their jobs, they buy more ramen noodles. That's what we are talking about here. Let's go back to the normal side of the ledger, because we do draw one more distinction there. So as soon as the income elasticity of demand turns positive, we are referring to that as a normal good. But there is that pivot point of 1. So between 0 and 1, as people's incomes go up, they buy more of these products, but not as much more as their income goes up. And we refer to that as a necessity. While products that people spend proportionally more of their income on, even as income increases, we refer to those as luxuries in economics. And again, you got to be a little bit careful with the language there. So these are technical terms here referring to ranges of elasticities. And those luxury necessity terms aren't quite what you would expect them to be from ordinary English. For example, there was a meta-analysis from the National Institute of Health maybe 10 years ago or so that showed that across the various categories of alcohol, beer, wine, liquor, that sort of stuff, alcohol is a normal good. People buy more or probably higher quality as incomes go up. But that elasticity in that meta-analysis was 0.32, I think, or something along those lines, so less than 1. So if you look at the economic definition here, that would mean that alcohol then is in the category of a necessity. So that's correct when we're talking about the range of the elasticity it falls into, but of course incorrect in the sense that, you know, it's not a necessity to life. There are many people who live their entire lives without drinking any alcohol at all. Let's finish up by looking at the cross-price elasticity as well. Oh man, we've got a lot of rows here, but it's not as hard as it looks. So cross-price is a funny term to begin with. What we're talking about here is, normally when we look at the price elasticity of demand, what we're talking about is how much less do people buy as the price of that product increases. We use the term cross-price when we mean what if the price that increases, whose impact we want to analyze, isn't the price of the product we're looking at, but the price of a different product because it's related to the product we are looking at. So, here's the stereotypical example. Let's say we want to look at what happens to peanut butter sales if jelly becomes more expensive, right? Like there's a connection between those two. That's a cross-price elasticity. So looking at the formula here, we're still doing percentage change in quantity demand over percentage change in price, but the price is not for the quantity of the product we're looking at. That's what makes this different. And of course, as the baseline here, we have the number 0. If the price of a product changes and it doesn't affect the quantity of the other product, those two are unrelated. And of course, lots of products are unrelated. Toothpaste becomes more expensive. How does that affect shoe shine? Probably, hopefully, not at all. But, once again, positive and negative numbers here. We're pivoting around the point 0. So positive. What's positive mean? Price of one product goes up, quantity of the other one goes up. That happens when these two products are what we refer to as substitutes. Gasoline becomes more expensive. People buy more hybrid vehicles, right? Because they allow you to consume less gasoline. I'm using this example deliberately because, again, substitute is a specific economic term. It refers to a positive cross-price elasticity of demand. You still put gasoline into a hybrid vehicle. It's not quite, what that English term substitute might suggest to you here. It simply means price of one goes up, people buy less of the other. That's it. That's all substitute is. And then within this substitute category, we can do our usual distinction. Hey, is that effect greater or smaller than 1? So if two things are substitutes but not very strongly, cross-price elasticity is still less than the number 1, that'd be an inelastic substitute. But if they are excellent substitutes for one another, so price of one goes up, people increase quantity even faster into the other product than price of the first product is going up, they're elastic substitutes, and that's just going to be great there for consumers to just switch away. And now we go down into the negative numbers. If we're looking at the cross-price elasticity of demand, that's a negative number. So price of a product goes up, people buy less of the other product as a consequence. That means those two aren't substitutes. Those two are the things that are consumed in combination. Once again, pardon the stereotypical example, your peanut butter and the jelly. The jelly, if it's up in the store, we expect people to buy less peanut butter. Or vice versa. If there's a sale on jelly, price down, we might expect people to not only buy more jelly, but also more peanut butter. Complements. And we again draw that standard distinction here. How strong is that effect? If the effect is negative, but in absolute value less than 1, that's an inelastic complement. And then if the effect is even less than negative 1, so greater in absolute value there than the number 1, however you want to think about it, those are highly complementary products. Those are elastic complements. So these are two specific final elasticities of demand we're looking at, but I want to mention one more time. You can calculate elasticities between any two things, right? Like you run a factory and there's a production process you have, and maybe you can use some automation, some robots, maybe you can use some people. What's the trade-off between the machines and the people? You could calculate an elasticity between the robots and the humans. You can do elasticities between anything, and it's very helpful for making optimization decisions, which is, of course, sort of the job of economics to begin with. But for us, we are now done, at least with a direct discussion of elasticities. So in this module, you learn to analyze the impact of price elasticities on revenue, how elasticities can be used to predict changes in equilibrium, explain how the price elasticity determines the incidence of attacks, less elastic side ends up with more of the attacks, and calculate a couple of other elasticities along with a reminder that there's a whole range of elasticities you could calculate in theory. I will see you next time.